Section 7.3 is on triangle similarity. Angle, angle, side, 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 and side, angle, side. How do I prove triangles are similar using angle, angle, side, 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 and side, angle, side similarity? So this might look familiar to you because we did do proofs of congruent triangles earlier this year. And now we are switching gears and we're going to prove that triangles are similar. So remember, similar means they have the same shape, not necessarily the same size. And so the theorems that we use are a little bit different, even though they look the same. So if you're given two triangles, you can ask yourself, are two angles of one triangle congruent to two angles of another? And if that's true, then we can prove that the triangles are similar by angle-angle similarity. And if you remember, angle-angle-angle was not a theorem to prove that triangles are congruent. If three sides of one triangle are proportional to three sides of another, that means they are similar by side, side, side. And that's what we've been working on in class, showing that they're proportional, showing that they have equal ratios. And the last one, if two sides of one triangle are proportional to two sides of another and the included angles are congruent, then we have side, angle, side similarity. So there's only three theorems that we can use to prove triangles are similar. This one says, explain why the triangles are similar and write a triangle similarity statement. So I recognize right away that angle A is congruent to angle D, and that's given in the picture. And I also can say that angle ACB is congruent to angle DCE because those are vertical angles. You might remember that from earlier this year. All vertical angles are congruent. And so that means that triangle ABC is similar to triangle, and here's where you got to be careful, you got to match the letters. So A is congruent to D, B is congruent to E by angle-angle similarity. I showed that two angles of one triangle are congruent to two angles of the other, and that means these triangles are similar. You might notice that this triangle looks smaller than this triangle, and that's because similar triangles aren't necessarily the same size. All right, let's look at the next one. It says, explain how you know the triangles are similar and write a similarity statement. So even though we are proving, we're proving using an explanation. All right, so I see that 92 is congruent to T, so angle Q is congruent to angle T. Now, is angle R congruent to angle V? No, I see 49 degrees and 39 degrees. So we're going to do a little bit more math, and let's find angle U here. 92 plus 39 is 113, and 180 minus 131, I said 113, didn't I? 131 is 49 degrees. So angle U is 49 degrees. Now we can say that angle R is congruent to angle U by the triangle sum theorem. And then these triangles, triangle RQS is similar to triangle. So R matches with U, Q matches with T and V by angle-angle similarity. Let's try number 2. Right away I notice I don't know any angle measures in this picture. But I do know that angle HJG is congruent to angle LJK by vertical angles. Next, I see side lengths. So I'm going to write the proportions. I'm going to do HJ over JL, so 18 over 27. And how did I know to match it with 27 and not 24? Well, if I look at this triangle, 18 is the bigger side. And then if I look at this triangle, 27 is the bigger side. So I'm going to match the longer side with the longer side. And I'm going to reduce this fraction by dividing by 9. I get 2/3. I'm going to do the same thing with the other sides. So 16 matches with 24. And I'll divide the top and bottom by 8 to get 2/3. Since these are the same ratio, we can say that sides HJ over JL is equal to GJ over JK. So the sides are proportional. So triangle HJG is similar to triangle. So we have to be careful. What would we match HJ with? We said HJ matched with this one. So LJK by, and this was side angle side similarity. Okay, and this last one on this page says verify that these are similar. So if these are similar and we don't know any angles, then we're going to be using side, side, side. And to do that, we're going to write 3 different ratios. 12 is the biggest number in this triangle, so I'm going to match 12 up with the biggest number in the other triangle and reduce it. 12 over 15 can be reduced by 3, so 4/5. And I can do the same thing with 12 over 15. And lastly, 8 over 10. And so triangle ABC is similar to triangle. A would match up with M, MNP. And actually for this one, it doesn't matter. It could be MPN as well. And the theorem is side, side, side similarity. So I have one of each type here. Showed you angle, angle, angle side, or side, angle, side, and side, side, side. All right, thanks for watching.